Welcome back to the Oliver School Construction Project. We are here at show number 3, and today we have Chase Gibson from SMMA, and we are going to be talking about some HVAC, correct?
Yes. So the HVAC systems are the heating, ventilation, and air conditioning systems. A highlight to this school is that this school will be fully air conditioned. Christian and I actually went and visited some of the students that will be the first graduating class of Lawrence Oliver last fall. And we were standing in a classroom that was, I think, somewhere north of 85 degrees with a big box fan blowing in the window. And when we told the students that there was going to be air conditioning at their new school, they were all completely thrilled and excited. The previous school that was in this site was built in the 1920s. It had basically one thermostat for heat for the entire building. The boiler was running on a loop. It was heating the building. You had a little bit of control in each individual classroom. It barely had ventilation. There was a mix of operable windows and some shafts that had non-powered ventilation, so they got some drafts in the winter, but that's about it from a ventilation standpoint. And so we are dramatically improving the precision heating, giving cooling, and then also allowing ventilation. So this will be a dramatically better environment from an HVAC standpoint.
And in a post-COVID world, we've learned a lot in the schools and elsewhere that you need the ventilation with especially that many students. They're talking about 1,000 students plus staff in the building, so that's really important.
Yes. In the post-COVID world, we've been looking at different things of creating air changes of outside air. We've been looking at different filtration requirements, so we are providing MERV 13 filters. We are filtering out different particulate and providing the best environment possible.
Fantastic. All right. So can you show us some of the equipment that has been installed that is going to help with that?
Sure. If we start looking up, right down the middle here, we have this fabric duct. This duct is going to be providing the ventilation air for the space. Additionally, we have 4 ceiling fans. This helps with destratification. If you've ever been in a space where it's much hotter up towards the ceiling and then cooler down at the ground level, this helps make it so that the space is one even uniform temperature. It also provides cooling. The kids running around in the gym, you can turn on the fans, and the fans can provide cooling without having to turn on the compressors and air conditioners. This ends up saving energy both for heating and cooling.
So a fabric duct, I've never seen something like that before. How new is that, and what are those black holes?
Yes, so it's not all that new. It is a bit of a niche product. We especially use it in gyms, in large auditoriums, and kind of spaces kind of a larger nature. The upside to the fabric ductwork is that instead of having diffusers everywhere, we can just put those black holes in the ductwork that are nozzles and are providing air that is distributed throughout the space. So normally, as HVAC engineers, we're trying to distribute the air as much as possible so that there's not hot spots and cold spots. And by doing something like this, we're able to spread out where the airflow is going to so that it's as even as possible. This area is provided by an energy recovery unit. So you may have heard of the term air handling unit. HVAC engineers are notoriously creative. An air handling unit handles air. An energy recovery unit recovers energy. It also functions as an air handling unit in that a energy recovery unit is both supplying air and then it is taking air out and taking energy out of the exhaust. And so in the winters in Lawrence, we're talking about temperatures pretty close to 0 degrees Fahrenheit, while inside in the space, it's about 70 degrees. And so why exhaust all of that 70-degree air if we can harvest some of the energy from it and then put it back into the supply? And so we have an energy recovery unit that is about 90% effective at recovering energy, which means if you have 0-degree outside air and 70-degree inside air, we can bring the outside air all the way up to 63 degrees, 10% less than what the current space is, which makes it so you don't have to spend as much money on heating.
What is the fuel being used to run the HVAC?
This building is going to be all electric. This project was started just in the shadow of the Merrimack Valley gas explosions of 2018. And as we had conversations with the district, it was very important that we moved in an all-electric direction and help remove this building from fossil fuel use. I think from here, let's move up to one of the classroom spaces.
So we were down in the gym and we were talking about some of the ductwork and things. So it looks a little different than that special fabric duct in the gym. What is going on in this classroom?
Yes, so we're now into one of the kind of typical classrooms for the school. In this classroom, we have our heating and cooling provided by VRF. So this cassette unit is a great way to do heating and cooling because it doesn't require any ductwork. And so it just has 2 refrigerant pipes and then a condensate drain pipe going to it, and it ends up saving a lot of ceiling space. And so this helps us to get higher ceilings in the classrooms and get a space that doesn't actually require as much coordination and is therefore less expensive for the contractor and for the owner. Outside of that, we then have over here, we have our ventilation. And so again, we have heating, ventilation, air conditioning. So that was the heating and air conditioning. Up here, we have the ventilation. Each classroom has roughly about 25 people in it. In HVAC terms, we need to provide a certain amount of air per person and a certain amount of air per square footage of space. And so for classrooms, we end up needing to provide 400 or 500 CFM of air per classroom. We do that with this system, and we do that as a decoupled, which just basically means the heating and cooling are separated from the ventilation, and this makes it so that we can very efficiently provide the air while minimizing the amount of ductwork, but also maximizing the comfort in the space.
We talked downstairs about the black holes being the diffusers, so this would be the traditional that's covered in blue plastic?
They're currently covered in blue plastic, which is an aspect of construction that during construction we don't want all the dust getting into the duct system, and so that is helping protect it so that it is all nice and clean when the students get here. Additionally, we can note that this is a VAV box, which is a variable air volume box. There's a certain amount of air per person, and then there's a certain amount of air per square foot. Mm-hmm. What happens when there's not that many people in the classroom? How does the HVAC system know? In this school, we're using demand control ventilation, which is a fancy way of saying that we're having a system check how much CO2 people are breathing out. And as those values increase, the amount of ventilation provided into the space increases. That way, the VAV system can modulate the air up and down based on how much is needed, because sometimes classes are occupied, other times the students go to lunch, the teachers go to lunch, and we don't need as much ventilation anymore.
Well, they were talking about modern buildings, but you really don't think about that when you're talking about what you're breathing, but that's pretty amazing.
Yeah, we are always trying to focus on how we can save energy, but in a way that still provides the maximum amount of comfort and safety to the occupants.
So we wanted to see the roof, so we can see a portion of the front roof,
yes.
Because you wanted to tell us what's out there.
Yes, so we talked about the VRF, or variable refrigerant flow system, that we have in each of the classrooms as the cassette unit, kind of decoupled heating and cooling. It has to reject heat somewhere, and so that somewhere is right here. We have the outdoor condensing units, and basically in the summer, these reject heat and therefore are able to cool the building, and in the winter, they actually suck heat out of the air so that they can actually put more heat into the building. And so although we talked about the building being all electric earlier, and I'm sure some of you kind of just cringe at the thought of all electric heating because you're like, how expensive is that going to be? Electric baseboard heating has a COP of 1. And this basically means for 1 unit of energy in, you get 1 unit of energy out. When we use heat pumps, they have a COP that is at least 2 and all the way potentially up to 5, depending on the outside temperature. And so it means when it's 50 degrees out, if you put 1 unit of energy in, you get almost 5 units of energy out. And so it means that they're a much more efficient way of heating a building. In addition to that, the architects worked on creating a very tight envelope with wall insulation values well above code, windows that also have a very high insulation value and are not allowing much air leaking. And then the roof that is also very insulated so that we aren't gaining heat or losing heat through it as well. We do all those things so that we use less energy while also using the all-electric energy.
And it's the heating system is not on currently, correct?
The heating system for the building is not turned on yet. Currently, as we're in the building, they have been using some temporary heating measures
if they were to turn on our heating system, they would then have to do a whole bunch of cleaning of the ductwork to get rid of all the construction debris. It would also have the potential of voiding a warranty. They generally do not turn on the systems until most of the finishes are complete.
But we can attest to the quality of the insulation, because it is definitely, I'm still wearing winter coat inside, but I do not need it.
I have shed my winter coat 2 floors ago. There's dramatically less losses through the envelope than on historic buildings. That is something that is much improved in the new building.
Definitely. Impressive, and the students and teachers will be thrilled, I'm sure.
Yes. Because it means there's also less temperature differential for space.
Chase, we have learned a lot about HVAC today, but you've taken us to this amazing room. So what is behind us?
Yes. So we are now in the mechanical room. So this is the energy recovery unit that we talked about when we were in the gym. And it is the unit that is bringing in all of the outside air into the building. This particular unit is an energy recovery unit that's about 10,000 CFM. A CFM is about the size of a beach ball. And so you can picture this unit spitting out 10,000 beach balls per minute for the entire school day. These are the fans that are pushing through the unit, either out into the building or are recovering energy and pushing it out of the building. We then go to here where we have the coils. Since this unit is refrigerant based, these coils actually do both heating and cooling with refrigerant. Next up, we get to the filters. So these are those MERV 13 filters. This is what takes all the particulate out of the air and makes it so that the air is safe and good for us to be breathing. And then next up is the energy recovery. This is actually a rather interesting form of energy recovery. It's a block. The air is coming through one side and then pushing through the other side, and it keeps switching which side it's going through so that it can recover more energy.
And the block, is it made of something particular to help the process?
Yes, this would be an aluminum block that has a very good heat transfer coefficient. It also has a desiccant coating on it, which is a fancy way to say that's a way that the all-metal core can actually harvest humidity from the air as well. In the winter, it gets very dry outside, and we want to keep as much humidity in the building as possible because keeping a relative humidity between 40 and 60% really helps people functioning better. And so this helps keep the humidity as high as possible without putting in rather expensive humidification systems.
Chase, this has been awesome to learn so much, and this is a cool place to stop. I still have 10,000 beach balls image in my head, but thank you so much for joining us today. We appreciate it.
Yeah, thank you for having me.
Hey, Steve, it's good to see you. We were just walking around the building with Chase, and we thought we'd come back up to our favorite level 3 to see what's new with you.
Yeah, awesome. Welcome back, everyone. And up here on the 3rd floor again in one of the typical classrooms with some new updates on the work happening here. Getting into some of the final elements of the finish work for the building. So starting off with the VCT flooring in the classrooms that has started to be installed throughout levels 3 and 4. Most of the classrooms do have the VCT flooring tiles and then the rubber wall base around the perimeter of the classroom. Also on level 3 as well, the ceiling tiles are starting to be installed now that our above ceiling inspections are completed. We call that just flooding the ceiling, which is when the contractor just puts all these ceiling tiles in that don't have any lights or sprinkler heads already in them. Makes the space feel really complete now without being able to see all the duct work and overhead electrical work going on above the ceiling. One other new scope that has started up as well is the install of the doors and hardware throughout some of the upper floors. So right behind me you can see one of the first few rooms where the classroom door was installed. So the process there is that the doors are swung, so attached to the hinges and attached to the frame, and then after that installed with the hardware. So the door lock set, maybe a wall stop so the lock set doesn't crash into the wall, sometimes kick plates as well for heavy traffic areas. So that's another scope of work that is new for this month.
Steve, do you have any fun facts for us this week?
While we were just talking about doors, the fun fact question of the month is how many total doors are there in the new Oliver School?
And the answer is?
Over 300 different doors.
Wow.
Yeah, a lot of doors, all different types. Yeah, that's the fun fact for this month.
We are back in this beautiful gym with those gorgeous windows behind, but what else is new in here?
Yeah, so a lot of exciting work happening in the gym over the last month. The gym equipment installer has mobilized to install the basketball hoops within the gym. So there's 6 total hoops, 1 full-size court, and then there's 2 shorter courts going the opposite way as well. Behind me as well is the scoreboard for the gymnasium. That'll be wired with power and connected to the shot clocks that'll be on the main hoops. And then overall, the rest of the finishes above are basically complete in this room with the AV system, AV speakers, the overhead ceiling fans for the HVAC system. So we're pretty close now to doing any final touch-ups and punch list work overhead before we start the install of the wood flooring heading into February and March.
I don't see a basketball yet, so we're due for some hoops at some point, right?
Yep, at one of the episodes there will be a little basketball game going on. We did make the first basket officially in one of the hoops, so they're ready for action.
We're down in the kitchen area now, which is also looking different, and we have a different host with us. Nate is joining us from Consigli. Thank you for joining us today.
Thank you for having me.
So when we were here with Steve a couple months back and we saw hoods, we saw some just open spaces. Can you tell us a little bit about what's new in the kitchen?
Yeah, since then, we recently had the delivery of all the kitchen equipment. So you can see the ovens here, mixing stations, the cooking counters, the pot racks, the electric mixer behind you, the serving counters. Everything's now here, ready to be installed. Hook it up to all the electrical and plumbing, and make it ready for cooking and serving food to all the students. There'll be a lot of food cooked down here for sure. Serve all the kids. Like you said, 1,000 students in this building, so a lot of cooking space and a lot of space that we can eat as well.
We are in what's going to be the cafeteria, correct? And what is new in this? Are we supposed to look up, I think?
Yes, the new feature of the cafeteria that's been recently installed is the cloud ceilings. So similar to the classroom, it's acoustic panels in a ceiling grid. They're called clouds because they're separate from each other and not continuous all the way to the edge of the perimeter of the room. The unique feature about these ones are they are at a certain angle, which helps with the acoustics of the room. As many people know, cafeterias with a lot of children in them tend to get very loud. So the angling of the ceiling helps deflect the noise and keep it less quiet and disruptive to the surrounding areas.
Steve was telling us about flooding the roof tiles or ceiling tiles early, so that hasn't happened yet. They were looking at the grid?
Yeah, this is just the ceiling grid with the lights installed at each angle. We are still awaiting inspections above head. Once we get the okay for that, we finish up punch list for above the ceiling. We'll then flood it just like all the other floors, like Steve had mentioned.
We are now with Ben from Consigli, and thanks for joining us.
Thanks for having me. So we're up here on level 4 now. As you can see, we've seen a lot of yellow so far, but this floor here, this tile and this paint is actually green. So each one of the different levels here has a different theme color. So we have yellow downstairs, we have green up here. If they go up to the 5th floor, it's teal tile and paint up there. Some other good items to point on. So behind me here, you can see these toilet partitions. So now that we have some of our plumbing fixtures, like our toilets in, we can start putting these partitions in. These actually form up the stalls of the individual bathroom stalls here. So that's a big update.
And we had seen these really cool sinks. They're my favorite sinks. But across from the sink, I see that there's something that's been installed in the hallway as well.
Yes, so we actually have been installing some lockers as well. So up here on the middle school floors on 4 and 5, we have these lockers for storage instead of the cubbies that we might have seen downstairs in some of the other classrooms. So for some of the older kids, rather than having the stuff in their classrooms, they have their own individual lockers out here in the hallway.
We just came out of the bathroom sink area, and there's some shelving in this window. What's happening in this classroom?
So behind me here, we have the millwork display case here. So the idea is that the students in the classroom can put stuff on display that they've created. So a hallway can see here. So as you can see, it's a two-way view here. So kind of a cool feature. These have been going in a couple of the classrooms here up on 3, 4, and 5. Just a cool feature for the students to show off some of the work they've completed.
We are still on level 4, correct?
Yep.
We just came up the hallway a little bit, and there's an interesting counter type thing. What's this?
Yes, so here we have our corridor countertops. So the idea here is that these countertops are between the classrooms. So it's kind of a breakout space for the classrooms where students can come out and work outside here as a separate space from the classroom. We also have the outlets installed as well. So there's power here so students can use laptops and other devices. But it's really just a shared space that the students can come together and use.
Well, there's a lot of flexible space. And I think I recognize somebody up the hall a little bit. That maybe Nate can tell us what's going on up this way. Hey, Nate.
How's it going? So in each of the hallways on each level 3, 4, and 5, there are corridor benches. Some of the other areas in the building also have them, as the old building does, in between the old arches outside the classrooms and the hallways as well. So a nice area for students to hang out and decompress in between classes and in the hallway.
Nice. Are they comfortable?
They are very comfortable, yeah, and they look great as well.
It was a good idea to try the bench. It's very comfortable. I agree, Nate. And thank you. We've had a lot of fun today. Ben and Nate wrapped the show up for us. We learned a lot about HVAC as well and all sorts of other new things in the building. So we appreciate you watching. Check us out next time.